Hey there, AI is moving so fast these days, it's even making the experts scratch their heads. We're all hearing about the crazy things these large language models or LLMs can do,
Yeah,
writing poems, composing music, even having conversations that make you wonder if there's a real person on the other side.
it's pretty wild.
But here's the thing even more impressive, is their growing ability to actually reason.
Right.
And you wanted us to do a deep dive into the latest research on this.
Absolutely.
Specifically, a paper called LLMs can easily learn to reason from demonstrations. Structure, not content, is what matters. And let me tell you, this paper's got the AI community buzzing because it kind of turns some of our assumptions about LLM learning upside down.
Well, what we're seeing is a move beyond just mimicking human language.
Yeah.
We're starting to see these LLMs grab the logic behind problem solving,
Yeah.
and that's where things get really exciting.
It's almost like they're learning to think, which sounds kind of spooky,
Yeah.
but also incredibly cool. So the researchers in this paper worked with an LLM called Q2.5-T2B Instruct,
Mm-hmm.
and they wanted to see if they could boost its reasoning skills without using massive amounts of data.
Right.
And what they discovered was pretty mind-blowing.
The team employed a technique called distillation,
Okay.
where they essentially used another powerful AI DeepSeek R1 as a kind of reasoning coach for the LLM.
Interesting.
So DeepSeek R1 would provide step-by-step examples of how to solve problems.
Oh, wow.
And Quen 2.5-32B Instruct learned from these demonstrations.
And here's the kicker. They only needed around 17,000 of these reasoning samples.
Right.
That's practically nothing compared to the billions of data points typically used to train LLMs.
Yeah, it's a tiny fraction.
So they're getting incredible results with a fraction of the data.
The performance gains were remarkable on a challenging math benchmark called AIM 2024. They saw a 40% improvement.
Wow.
Similar gains were observed on a coding benchmark called Live Code Bench.
So we're talking about this LLM trained on a relatively small data set, starting to perform on par with some of the big names in reasoning AI.
Exactly.
What's the secret sauce here?
Well, they also used a technique called LoRA,
Laura.
which stands for Low Rank Adaptation.
Okay.
It's a way to fine-tune an LLM by updating only a small fraction of the model's parameters.
So instead of rebuilding the entire engine, they're just giving it a targeted tune-up.
That's a good way to put it, yeah.
Did using Laura impact the performance at all?
Not at all. What's fascinating is that LoRA achieves comparable results to full fine-tuning,
Really?
and in some cases even better results, especially for reasoning tasks.
Wow.
It's a far more efficient approach.
This could be a game changer if we can develop powerful reasoning AI using significantly less data and processing power. It opens up a world of possibilities.
For sure.
But let's get to the heart of the matter.
Okay.
What was it about this approach that yielded such impressive results?
The central finding of the paper is that what truly matters for teaching LLMs to reason is the structure of the reasoning process, not the specific content of the examples.
Okay.
Instead of stuffing an LLM's head full of facts and figures, they focused on teaching it the principles of logical thought, giving it a framework to hang all that information on.
Okay, so it's not just what the LLM learns, but how it learns? That's a pretty significant shift in thinking.
I think so.
But how did they actually prove that structure is the key?
They conducted some fascinating experiments where they intentionally messed with the training data.
Okay.
First, they disrupted the content of the examples.
Okay.
They did things like giving the LLM math problems with deliberately incorrect answers, randomly swapping numbers, and even removing words LLMs typically use when reasoning.
So they threw all this chaotic, jumbled information at it. And what happened?
Well,
Did the LLM short circuit?
here's the surprising part. Its reasoning abilities were barely affected.
What?
Even with errors in the data, it could still grasp the underlying logic of the problems. This suggests that the LLM is learning a sort of universal reasoning structure that it can apply even when the details are wrong.
So content didn't matter much, but what happened when they messed with the structure of the reasoning? The actual steps involved in solving a problem.
That's where things got really interesting and where they found the key to effective reasoning in these LLMs.
Okay.
We'll dive deeper into that right after this.
Okay, so messing with the content of the training data barely made a dent in the LLM's reasoning ability. It could still figure things out even when the information was wrong. That's pretty wild.
It is, yeah.
But I'm really curious about what happened when they started tinkering with the structure of the reasoning process.
Right, so this is where the researchers really got to the heart of how these LLMs learn to reason.
Okay.
They disrupted the logical flow of the problem-solving steps, trying things like randomly shuffling the steps, deleting some, and even inserting irrelevant ones from other problems.
So it's like they took a perfectly good recipe and started scrambling the instructions.
Right.
Adding in steps for making a souffle in the middle of baking a cake.
Exactly.
What happened to the LLM's reasoning abilities when they did this?
These structural changes had a huge impact. The LLM's performance plummeted.
Really?
even though the individual steps themselves were often perfectly fine.
Wow.
It really highlights just how important that logical flow is,
Yeah,
that step-by-step coherence in the reasoning process.
right.
It's not enough to just have the right pieces they need to be put together in a way that makes sense.
That makes perfect sense. It's like if you're trying to build a house, you can't just randomly nail boards together and hope for the best.
Right.
You need to follow a blueprint, a plan, to create something that's structurally sound. So the LLM needs a reasoning blueprint to really understand how to solve problems effectively.
Exactly.
What can you tell us about the specific ways they messed with the structure and how that impacted the LLM?
Well, let's start with the leading steps.
Okay.
They found that the more steps they removed, the worse the LLM performed. But what's really interesting is that simply giving the LLM the final answer,
Yeah.
along with a detailed explanation, wasn't enough to teach it how to reason.
So it's not enough to just show the LLM the destination it needs to see the whole journey, the twists and turns, the dead ends.
Yeah.
Why is that so important?
It suggests that those moments of backtracking, self-correction, and reflection are critical learning opportunities.
Okay.
The LLM needs to see how to deal with errors and refine its thinking,
Yeah.
not just how to arrive at the right answer. It's about understanding the process of reasoning, not just the outcome.
That's a great point. It's like learning to play chess. You're not going to become a grandmaster just by watching someone else win a game.
Exactly.
You need to see how they analyze the board and anticipate threats, recover from mistakes,
All right.
to develop your own strategic thinking. Okay, so deleting steps mess things up.
Yeah.
But what about when they started inserting those random, irrelevant steps?
That created a lot of confusion for the LLM as well, even though the individual steps were often logically valid. They
Okay,
didn't fit together coherently.
I see.
It's like trying to follow a recipe that includes instructions for changing a tire in the middle of baking a cake. You might end up with a very strange cake, and the LLM ended up with some very strange solutions.
So it's not just about having logically sound steps.
Right.
It's about those steps fitting together in a way that makes sense. There needs to be a narrative, a story to the reasoning process.
Us.
What about when they shuffled the order of the steps?
That was perhaps the most disruptive change of all. Imagine trying to solve a jigsaw puzzle where all the pieces are in the box,
Yeah,
but they're arranged in a completely random order. It would be impossible to see the bigger picture and put the puzzle together.
right.
That's essentially what they did to the LLM. They jumbled up the order of the reasoning steps, and the LLM couldn't figure out how to solve the problems.
It's like a detective trying to solve a crime. The clues might all be there,
Yeah,
but if they're not pieced together in the right sequence, the case will remain unsolved.
exactly.
It sounds like this really emphasizes the importance of logical sequence in the reasoning process.
Absolutely. It's not enough to have the right pieces.
Right.
They need to be arranged in a way that follows the rules of logic and builds towards a solution. It's about creating a coherent and meaningful narrative for the LLM to follow.
Okay, so we've covered how deleting, inserting, and shuffling steps all negatively impacted the LLM's performance. It seems like the big takeaway here is that teaching these models to reason is less about the amount of data and more about how that data is structured.
That's exactly right. It's about instilling those principles of logical thinking,
Right.
that step-by-step coherence.
It makes me wonder if there are certain LLMs that are better at picking up this reasoning blueprint than others.
That's an interesting thought, and it's something the researchers explored a bit further in their work. They compared this data-efficient, structure-focused approach to another technique called best-of-n sampling.
Best of N sampling, what's that all about? Best of N sampling, it sounds like some kind of AI talent show where the models compete for the top prize.
Well, it's not quite a talent show,
Okay,
but it does involve exploring multiple possibilities. So with best-of-n sampling, you have the LLM generate several different responses to the same prompt.
okay,
Then an oracle, which could be another AI or even a human,
right.
picks the best response out of all of them.
So it's like having a panel of judges evaluating different solutions and choosing the winner.
Yeah, you could think of it that way.
I can see where the talent show analogy comes in. What did this best of N sampling reveal about the LLMs and their reasoning abilities?
The researchers discovered a strong correlation between how well an LLM performed after this data-efficient reasoning training and how well it did with best-of-n sampling before the training.
So if the LLM was already good at picking the best answer out of multiple choices, it was more likely to benefit from this new training method that focuses on structure.
That's exactly what they found.
Interesting. So it's almost like some LLMs have a natural aptitude for reasoning.
It seems that way.
It makes you wonder if we could develop some kind of reasoning aptitude test for AIs.
Yeah.
Like an SAP for logic to identify those with the potential to become super reasoners. But before we get too far ahead of ourselves, I'm curious about how this new approach stacks up against more traditional training methods, Did they compare the two?
They did. They compared their data-efficient, structure-focused approach to a technique called shortcut fine-tuning.
Shortcut fine-tuning.
With shortcut, the LLM is trained on examples that include short step-by-step solutions. Think of it as a crash course in reasoning.
Okay.
Whereas the structure-focused method is more like a full semester with a deep dive into the process.
Gotcha. So it's a difference in depth and focus. What were the results of this comparison?
The LLMs trained with the longer, more structurally focused examples outperform those trained with the shorter, more content-heavy examples. It really underscores that it's not just about the amount of information you're given LLM,
Yeah.
but about how that information is presented and the reasoning patterns it's exposed to quality over quantity when it comes to teaching them to reason.
This is such a shift from the bigger is always better approach that has dominated AI for so long. It's refreshing to see researchers exploring these more nuanced, more efficient approaches. It feels like we're moving away from brute force and towards something more elegant and sophisticated.
I agree. It's an exciting time to be working in this field. We're at a turning point in AI development. We're moving beyond simply teaching LLMs to mimic human language and starting to tap into their potential for genuine reasoning. And this research shows that the key lies in focusing on the structure of logical thought instead of bombarding them with data. We need to provide them with the tools and frameworks to think for themselves.
It's like we're giving them the keys to the kingdom of reason, not just a map of the terrain. What does this mean for the future of AI and for all of us who will be interacting with these increasingly intelligent systems?
The potential is enormous. This could revolutionize fields like education research and even everyday decision-making. Imagine having AI assistants that can not only process information, but help us think more critically, solve problems more effectively, and make better decisions. It's about empowering people with AI tools that can amplify our own cognitive abilities.
It sounds like a future where humans and AI work together, each contributing their unique strengths. Humans bring creativity, intuition, and empathy, while AI provides logical processing power and a knack for pattern recognition. It's a powerful partnership with the potential to solve some of the world's most challenging problems.
Precisely. And it's a future we're actively creating right now. The journey of teaching AI to reason has only just begun, but the progress we're seeing is remarkable. It's a journey filled with both incredible promise and some very real challenges, but it's a journey worth taking.
It certainly is. Well, we've covered a lot of ground today, from the technical intricacies of LLM training to the philosophical implications of teaching these systems to reason. Thank you for taking us on this deep dive into the world of AI reasoning.
It was my pleasure. It's always exciting to share these groundbreaking discoveries with those who are curious about the future of AI.
And to all our listeners out there, keep those minds open and those imaginations fired up. We'll be back soon with another deep dive into the fascinating world of AI. Until then, happy reasoning.